Welcome to Blender add-on development for beginners. In this module, we are going to extend our add-on development skills by looking at how we can create custom mesh objects. In the previous module, we looked at how to create a very basic add-on. It contained the minimal amount of code needed to install it in Blender and add an operator to a menu. That operator only dealt with objects and used an object attribute called location to move it around. Objects, however, come in various types, and in this module we will learn how to add custom mesh objects to the scene. In this lesson we will start with the backbone of the add-on and encounter some familiar items. The BL info dictionary to identify our new add-on, an operator class, although we won't implement the body of the execute method yet, and properties, for which we will look at how to add some extra checks like minimum and maximum values. In the other lessons in this module, we will develop the actual code that will add a mesh, and in fact we will look at two ways of doing the same thing, each with its own pros and cons. The operator we are going to develop will add a star to the scene, and this star can have a configurable number of points, as well as properties to set the inner and outer radius. If we want to create a star like we see here, we need to start with an empty mesh. We can then add the inner vertices, but we have to make sure they are in a perfect circle. Then we can add the outer vertices and again make sure they form a perfect circle. With all the vertices added, we can then create all the edges that connect the vertices so that they form a face. Rather complicated to do by hand, but pretty straightforward in a script with the help of some high school trigonometry. Another approach would be to use Blender's many built-in operators. We can call those operators from our own operator, and the sequence of actions would look something like this. We add a primitive circle with twice as many vertices as we need points in our star. Then switch to edit mode, vertex select mode, and then select all vertices. Then we use checker deselect to leave just half of the vertices selected and scale those relative to the star center. Each method has its own advantages. The first one gives us great control in positioning the vertices, in particular when we are creating complex objects. This doesn't matter all that much for a simple star, but this method is great if you want to create meshes based on mathematical formulas, for example. It is also really easy to understand because you literally add vertices, edges and faces one by one, building the mesh from the bottom up. The second method is more powerful and follows the modeling practices an artist would use. It also has the advantage of using Blender's many built-in operators, saving development time. Performance might also be better depending on the circumstances because the built-in operators are often implemented in C, not in Python. So which one should you use? The answer of course depends on the requirements and your personal preferences. We will have a look at both, and we start with building a basic framework for our add-on that can be used in both methods. The first part of the add-on should look familiar if you have watched the videos in the previous module. We start with a BL info dictionary that describes our add-on. We also import some modules that we need in order to define our operator. From the properties we import int property because the number of points in our star is an integer. And we need the float property for the inner and outer radius. We then define the operator that will add the star. We call it object under ot under add star and define some class level variables that Blender needs when we register the operator later. We then define the execute method, but we don't implement the actual code yet. We will have a look at that in the next videos. The poll method simply checks if we are in object mode. The rest of the code that registers the operator and creates a menu entry is almost identical to what we saw in the previous module. Just the name of the operator class is different, and we want to add our operator not to the object menu, but to the add menu. The internal name of the menu we figured out with the help of the Python tooltips we enabled in the preferences. Now let's add some properties. First, the number of points, an int property. We define the name that is shown to the user and give it a proper description. We set the default to 5 and we add some new constraints too. Stars with less than 3 points are rather meaningless, I think, so we define the minimum to be 3. We don't mind if a star with lots of points is created, but we do want to prevent the user from accidentally creating a huge number of points, so we set the soft max to 20. People can then still enter a higher number manually, but the slider at least will stop at this point. The inner and outer radius are float properties and look very similar. The names and descriptions differ, but they have the same structure, and we define a sensible default for each of them, as well as a minimum of 0, because a negative radius doesn't make sense. We do want to add an extra restriction though, and that is that the outer radius is always larger than the inner radius. So if the user slides the inner radius beyond the outer radius should move along, and vice versa. We cannot use simple parameters to define these constraints, but we can use a slightly more advanced solution using callbacks. All this is not strictly necessary, so feel free to skip this part and have a look at it later. Every time the value of a property is changed by the user, a function will be called to act on that change. This function can be configured on the property with the update argument. So here we refer to two functions, one that gets called when the inner radius changes, that may have to update the outer radius, and one that gets called when the outer radius changes, which may affect the inner radius. If we look at the update outer radius function first, we see that it receives two arguments. Self will be a reference to our operator, and context points to the context. Via self, we can access the properties of our operator, and here we check if the inner radius is larger than the outer radius, and if so, update the outer radius. The update inner radius function looks almost identical, but with the conditions reversed. Here we check if the outer radius is smaller than the inner radius, and only if it is do we update the inner radius. Now there is some risk here we should address. These functions are called when the value of a property changes, and they may change the value of another property, that in turn may also trigger an update function. We risk going into an infinite loop here, so our tests must be very careful. We prevent problems in the update outer radius function by checking if the inner radius is strictly greater than the outer radius, so not equal. If it is greater, inner radius will get updated and this will trigger the update inner radius function, but this also uses a strict check that will not trigger, because we made the inner and outer radius equal. Now let's run the script and see if it works. The add menu indeed has our operator, and when we select it, we see the properties. Nothing happens in our scene when we change them because our execute function is still a dummy, but we can see the limits on the number of points in action, and if we change the inner radius beyond the outer radius comes along, and vice versa. So far, so good. Remember to save the file and restart Blender for the next video. In this video, we talked about adding a mesh object to a scene, and we looked at the differences between the two methods, creating a mesh from scratch and creating a mesh using Blender's built-in operators. We implemented the basics of the new add-on, which is similar to the one we built in the previous module, but we did learn some new things about controlling behavior of operator properties, including how to use update callbacks. In the next video, we'll use the basic operator developed in this lesson and implement an execute method that builds a mesh object from scratch. In a later video, we will look at the alternative implementation that uses built-in operators. Thank you for watching and see you in the next one.